Okay. So the first part of this said if you can find those points P and Q, and you realize that the value of y when it crosses x has to be 0, and that we have a special name for this. It's called what? It's called what? Your x intercept. So I'll go ahead and write this here. So P, and let me write this a little bit. I should zoom in a little bit more. P and Q are x intercepts. And the value of y must equal to 0. So when is y equals x squared minus 3x minus 4 equal to 0? Well, at the zeros or at the x-intercepts. And isn't that a quadratic? Isn't that a quadratic? How can I solve a quadratic when it's set equal to 0? What are the methods I have? You can factor in, you can use quadratic formula, you can use completing the square. Why you guys are so smart? I'll talk to you guys over here that I hardly talk to. It's like I ignore you guys all class. So which one do you want to use? You want to use factoring? You want to use quadratic? Let's use, you want to use quadratic, but can you use factoring? Yes. X minus, yes. And you see the two answers there? X equals to 4 and x equals to -1. Now, quickly, if you want to use quadratic, you could use it. What's a equal to here? Let me use a different. Why aren't my pens? Not yet. Not yet. Look at the first part of the question. The curve y equals x squared minus 3x minus 4 crosses the x-axis at P and Q. So let's find those first. Let's find P and Q. Okay. So if you want to use quadratic here, A equals 1, B equals -3, C equals -4. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be negative of -3 plus or minus the square root of -3 squared minus 4 times 1 times -4 divided by 2 times 1. So x equals 3 plus or minus, and I'm about to break my surface pen. Square root of, for a surface, there's a new Surface Pro 9, which has a 12th generation CPUs on it. I gotta see if they're hybrid. I think they're hybrid technology, but it costs a lot of money. It's kind of overpriced, and mine is still working fine. You know, so I might wait until there's a special. What's 3 plus 5? 8 divided by 2? What's 3 minus 5? -2 divided by 2. There you go. So you get the same answers. In this case, if our discriminant was negative, then you would be dealing in the complex number set. And remember, the real number set is contained, well, the real number set is contained inside the complex number set. So the imaginary numbers, you can create real numbers out of imaginary or complex numbers. Because remember when we had no solutions when the discriminant was negative? It's two imaginary solutions. Yes, correct.
It's not no solutions, it's two imaginary.
Yes, but in the real number, if we're working in the real number system, we don't have any solutions there. But we have to create the complex number system. Or the complex number system creates the real number system.
But both things are the same thing.
That's what, well, yes, what we say is there's no real solution, but there are imaginary solutions. Yeah. Okay, good. Okay, so now it says the next part of this says, So we got the points. The points are, let me go ahead and write them here. Point P will be -1, 0. Point Q will be 4, 0. You could if you wanted to, but P comes before Q, so I'm gonna get, and I count from left to right.
Wrote it like that. He should be-
I agree with what you're saying, however, I'm gonna leave it that way. But I see what you're saying there. All right, the tangent to the curve at P and Q meet at R. So now we have to imagine the situation. We have a quadratic. We have 2 points, namely their x-intercepts, named P and Q. We have tangents to them. These tangents will meet at a point called R. Do you see what's happening there? So I think I want to sketch this for you. I'll try my best to make a sketch. Let me try my best. I will humbly try to make a sketch. First, let me make some straight lines. Here we go. Here's the first straight line. I think that's straight enough. Of course, I'm using a ruler, and you can see me using the ruler, so I can't even pretend like I have that out. And here we go. And then we zoom in on this. And now, instead of using a ruler to make my lines, I'm just going to eyeball it. So here's 4, oh no, not chat. Here's 4, 0. So this is going to be Q. 4, 0. And here's -1, 0. Now, you don't have to do this in the problem, but because I'm pretending to be a teacher now, I am going to try to visually represent this for you. Now, another point I can plot here is, can I plot my y-intercept there? What's my y-intercept when x equals 2? So it's -4, right? When x equals 0, we get a y of -4. So right here, this other point here, I'm gonna leave this, I'm gonna put it in black. This is our y-intercept. That's our y-intercept. These are our x-intercepts, P and Q. Our y-intercept is 0, -4. Now, you know what? I feel like doing my my vertex. I feel like doing my vertex. Okay? It takes some time to do, but there, it came up there. So there was a delay there of like 5 seconds. So I'm gonna do my vertex. How do I get my vertex, guys? Can you do completing the square? Yes. But now, how about my line of symmetry? Can I just get my line of symmetry here? What's my line of symmetry? My line of symmetry here will be x equals to -b/2a. That's a quick trick. In fact, half of your quadratic formula. Well, that's what's -b gonna be? What's b gonna be? -3. And what's a gonna be? So it's 3/2. It's 1.5. That's my line of symmetry. That's gonna tell me that right here, this line here is the middle of my parabola. This is my line of symmetry. It's also part of my quadratic equation if you looked at it. Half of your quadratic equation is -b/2a, but we always write it together. But in reality, this guy here is really -b/2a plus or minus the discriminant divided by 2a. We just combine it together to make it look prettier. But -b/2a is your line of symmetry. You don't have to do completing the square. But if you complete the square, what's half of -3? -3/2. And so it's 1.5. So now we're going to go ahead and put 1.5 squared. I'll do it over here. I'm going to go ahead and put 1.5 squared minus 3 times 1.5 minus 4 to get a number there. Let's just quickly do it because we're running out of time before lunch, and I'll pause it. 1.5 squared. Because I'm going to make a quick sketch of the problem. No, you don't have to do it. No, you don't have to do it. But if you're not thinking like this, if you can't think of it geometrically like this, you might not be able to do the problem. But thinking of it geometrically in your mind, you get the idea of what we're doing. So it's going to be 1.5 squared minus parentheses 3 times 1.5 parentheses, close it, and then minus 4. So I get negative 6.25. So this is the original equation for parabola. So now I know my vertex is 1.5 comma negative 6.25. That's what I got. Negative 6.25. So now I can go down here and put, here's 4, 5, 6, 7. So it's like right around there. So if I complete my sketch, my parabola looks kind of like that. Yeah, there's a delay. So now, if we go back to the question up here, it says the tangent to the curve at P and Q meet at R. So now I'm going to sketch quickly the tangents at P and Q. They meet at where? At R. So what I want to do now is I want to find the derivative of my tangent line here and here. Make an equation for both of these. There will be 2 different equations. Set them equal to each other to find their common point so I could find R. Right? So I'm going to go ahead and pause the recording right now. Yes, tangents will
follow like the parabola.
Yes, let me pause. Okay, so now we want to, I think we left off to, we got to find R. But in order to find R, we got to find each of the slopes of those tangent lines. Right? And is that team? There you go. It's like a 3-second delay or 4-second delay. Okay, so talk to me, guys. If we have Y equals, and I should do this in a more serious color. Give me 1 second. Red is serious, but not as serious as black. Rainbow. All right. Y equals x squared. So the equation here for that curve is y equals x squared minus 3x minus 4. So we want to find the slope of my tangent line, the derivative at those 2 points, P and Q, at -1 and positive 4. So talk to me. What is it? Y prime equals to what? 2x minus 3. So now we're going to find out the slope of the tangent line at, so first at x equals -1 and x equals 4, right? So here we go. Put it in there. Y prime equals 2 times -1 minus 3. So that's -2 minus 3. That's -5. So the slope at x equals 2, -1 is what? So this slope of this line here is what? What's the slope? -5. So now let's do the other side. Y prime equals to 2 times 4 minus 3. So that's y prime equals 8 minus 3. Y prime equals to 5. So what's the slope of this other line here? 5. Now, do we have the slope? Do we have a point? We have both things. So can you form lines with this? Can you write an equation of the line? Yes. So now you have the following information. You have a slope of -5 with a point of -1 comma 0, and you have a slope of +5 and a point of 4 comma 0. And y minus y of 1 equals m times x minus x of 1 is what you should be using. What is that called? What is that form? Point slope. So let's go ahead and do it quickly. Y minus 0 equals -5 times x minus -1. So that's y minus 0 equals -5 times x plus 1. So y equals negative 5x minus 5. Notice I don't have, when I do this team meetings like this and I do it up there, I don't have to stand up and move it again. All right, so we got one equation. So the equation to this guy here is y equals negative 5x minus 5. And now we do the other one, right? Y minus 0 equals 5 times x minus 4. So y equals 5x minus 20. And then you get the other side. So now you know that this side here is 5x minus 20. But now we want to find r. So we have a system. We have a system. The system is composed of these two guys. Y equals 5x minus 20. And y equals negative 5x minus 5. Now we have two methods of solving this. We can either use elimination or substitution. Which one do you want to use? You want to use elimination or substitution? Yes, you can. Yes, you can. Well, when we did it in class, we always did substitution. If the y's are the same, we set them equal to each other, right? I'll do the other method too. So here is a substitution. Substitution is just substitution. We just say, oh, the y's equal the y, right? They're the same for both of them when they cross. So we just say 5x minus 20 must equal negative 5x minus 50. And so when I add the 5 over, that's 10x, and I add the 25 to the other side, 15, right? And so x equals 15 over 10, which comes out to 3 over 2. Make sense? Okay, so now, if I tried to do this using elimination, I get the following. I can add both of these together. So this will be elimination. The key of elimination is you have to be able to cancel one of the variables. The way it's set up here, you can cancel 5x and negative 5x by adding both of them. So you get 2y equals to 0 minus 20 minus 25. So I could just write minus 25. But then you get y equals to negative 25 over 2. But the other one we solve for x. So let me show you how to solve for x instead. We're going to subtract then. Let's just, right? Because you are going to get 25 over 2, right? You are going to. But let's say I minus y, 1y minus 1y, that's 0. 5x minus negative 5x, that's 10x. And negative 20 minus negative 5, which is positive, is negative 15. And so when you add it over, you get 15 over, oops. It doesn't go back now. I don't know why. That's a bug. So that's 3 over 2 equals x. But if you put the x equals 3 over 2 into the x now, like into the original ones, you get the y that you want, because you need the x and y coordinate, right? The coordinate for x and y. So let's substitute it into the original one. So say you put y equals 5x minus 20. I like it better because it's, it's positive. I put 3/2 in here. Y equals 5 times 3/2 minus 20. You get y equals 15 over 2 minus 20. And then you do crisscross happy face. 15 minus 40 divided by 2, which is negative 25 over 2, which is what I got when I eliminated the x's up top. So remember, when I decided up here, when I did the substitution like this, when I said, oh, this is easy, I can substitute it real quick. Let me just cancel the x's. I added here, I got 2y, 0, x, 0. minus, this is a 5, sorry. Minus 25. And then when I solve that, it comes out to y equals negative 25 over 2. And look what it is, you know? And so if you put 25 over 2 into y, you're going to get an x of 3/2. But what's important here is that you just found r. R is 3/2 comma negative 25 over 2. So that means over here, now you know that this guy here is 3/2 comma negative 25 over 2. But now we're not done with the question. So I'll wait because some people are copying. Look at that. I'm pretending to be a teacher. But yeah, Desiree, I do remember when I was that age, I was the same way. I was like very opinionated. I thought I was right all the time. I thought I was smart. I always put people down. I still do, but differently. But I was mean spirited in that way because I was always in a competition. You know, yeah, I remember quite vividly. Oh my gosh. No, I was fit, but I was fit in periods. Sometimes I was fit, sometimes I was not. Sometimes I was fit, sometimes I was not. We got one now. We now get another one. Whoa, look at it. How many intersection points do we have? 1. But now we go back to the question up here. Now it says the normals at P and Q meet at S. So we come here. Let me draw the normals. Here's the normal. Normal does, and let me see if I can get a better angle here. This is almost normal. I don't know. Something like this. So in theory, here's the normal. The normal means perpendicular to. I can't remember the angle I put there, but I'm gonna just try and all right, whatever, somewhere there. There. This is not the best, but whatever. What does the normal mean? Perpendicular, and it meets here. These have to be perpendicular to the tangent. So can we figure out what the perpendicular slopes ought to be at P and Q? Yes. Do we have the tangent slopes? Yes. So now we come back here and we're like, okay, the slope of the normal lines at x equals -1. Well, what is it supposed to be? Well, tangent, -5. So m perpendicular to that is what? +1 over 5, because we flip it and we change the sign. Remember, we flip and change the sign. Negative reciprocal. So since it's already negative, we're gonna make it positive and we flip it. This guy here, look, you see it? And now for the other one, for x equals 4, the 5 was positive, so what's this perpendicular slope gonna be? Negative what? There we go. And now we do the same thing we did before, because what point did we have at -1? P was what? -1 comma Q, and Q was 4 comma 0. And so now we do y minus y's of 1 equals n times x minus x of 1 with these point and slope, because these are our normals, right? They're perpendicular. If something's normal to something else, it's perpendicular. So we have y minus 0 equals 1/5 times x minus -1. Y minus 0 equals -1/5 times x minus 4. So y equals 1/5 times x plus 1. So y equals -1/5 x plus 4/5, I think. And now let me finish the other one. Y equals 1/5 x plus 1/5. And now we got these two equations that are normals at P and Q to the tangent, obviously, right? And we're going to find the intersection point between them. So we're going to set them equal to each other, or we can use elimination, whatever you like. whatever you like. I'm gonna go ahead and use substitution because it's just easier for me to do a substitution right now, but it's easy to do the other one because they're set up nicely for us. So add over, you get 2/5 x plus 3/5 over here. Sorry. Equals 3/5. Multiply by the reciprocal, you get 3/5 times 5/2. Guess what it comes out to? 3/2. It's in the middle. Yes, but now we're working on the one up top. We're working on this guy here. Because we did the normals to it. We did the ones that are perpendicular to the tangents.
Why does it equal something?
Because they happen to cross the middle here.
So is the other one gonna equal something too?
Watch, what is, no, it's not, because it's gonna be up top. Look, watch. So let's go. So let's put 3/2. We put 3/2 into any one of the original ones. You could put it into there or into here. Right? So let's just pick the nicer looking one. The positive one. Y equals 1/5 times 3/2 plus 1/5. So that's 3/10 plus 1/5. Right? So 3/10 plus 1/5, that's 15 plus 10/50. Oh, that's 25/50. It's half. So S is 3/2 time comma half. Oh, right here, look. We're getting this guy. This is 3/2 comma half. This is S. Yes, yes. We had to do point slope again. So now we found both our R and our S. Notice the game we're playing here. We're doing chapters 1, we're doing chapter 3, we're doing chapter 4, and chapter 6, all in one question. And remember, what's the important thing at the beginning of class I put there? If it's attainable by a human, it's attainable by me. Yay, that's good advice, don't you think? All right. So again, for those of you who are like lost in this, there could be reasons for it that started back in 3rd grade and you just didn't know it, but it doesn't have to continue to be the reason now, but you need to change your attitude. Okay. Well, it's hard to do to change your attitude. How do you convince somebody to change your attitude? Anyways, so the final part is find the distance RS. Find the distance RS. So that's the final part of the question. We look at R and S and we're like, okay, can I find a distance? Well, yes. What's my distance formula? Distance equals the square root of y of 2 minus y of 1 squared plus x of 2 minus x of 1 squared. And so now I have R here, which is 3/2 comma -25/2. And I have S, which is 3/2 comma half. And so now you have the distance equals to the square root of, okay, 1/2 minus -25/2 squared plus 3/2 minus 3/2. So then the second part becomes, you could see it's half, it's plus, so it's 26/2 squared here, plus 0 squared. And then you have 13 squared plus 0 squared. So that's 13 squared. And then you have the square root of 169. That's 13. Or you could have just counted from, could have gone half, if it's vertical or horizontal, half minus -25/2 comes up to 13. You're gonna have to go draw a phone. Yay or nay? Now again, there are some of you here who are lost. But there's so many who are lost and have a good attitude. But most people who are lost have a poor attitude. So don't be that one. No need to complain. All right. So that's pretty much it for this question. This question targets each and every single one of the skills that you should have at this point, except for inequalities. And you're not really working with radicals here, but you're working with some exponents, but very little. Okay, fair enough? Is that a good question? I think it is. I think it is. So I'll wait because some people are copying, and then I want to do another question, and then I'll end the video there. And I guess I can pause it right now to save some time. Save some memory. Pause. Resume recording. So like you can do number one. That's the answer to that is 4x to the third plus 6x squared. You know, the answer to number two is 5x to the fourth minus 24x to the third plus 11, right? Now the answer for number three, you can do it, but you have to use distributive property and distribute 2x to the third and then do the derivative. Now you could use the product rule, but I haven't taught you the product rule. Same thing for number four, number five, number six, you got to FOIL it first. Number seven, rewrite it. So for number seven, you have to rewrite it as 3x to the 2/3. And now you can do the derivative. For number eight, maybe you should realize that this is x to the fifth over x squared plus x to the third divided by x squared plus 2x squared divided by x squared. And then you simplify that and then you do the derivative, right? And then you realize number nine is 4x to the negative third and then you do the derivative. Can you? My wife is sending me first grade math homework and saying, no entiendo, veo más respuesta bien que mal. No sé, mira, ve tú. I don't care. It's first grade. That's not even a real grade. All right, continue. 3x to the negative 4, right? What's the derivative of 50? What will be the derivative of 50? Yeah, the derivative here, if y equals to 50, then y prime equals to 0. This is x to the 1/4, so get the derivative. This one here is x over x to the third plus 3x to the third, right? You write it as x to the negative what? 2 plus 3x to the negative 3, and then you do your derivative. No.
Isn't this the video?
Yeah, this is the video. Use an online derivative calculator. That's how you spell calculator. So you go here. So you go here online, and you will go to derivative calculator.
Do you have to go like this?
No, well, I mean, I just don't want to do the answers, man. I'm sick and tired of doing this. I'll be honest with you. Steps. But this calculator might not be the best calculator for you. And you would just put the stuff in here and go. It's like if you don't do that one, but if you put it in there, you should be able to get step by step. But however, it might do like the product rule or something like that. It might be more sophisticated. So figure it out. No, that's for why would you have the derivative calculator? What a shame. I know he can't do class. So I'm just counting against him twice so he can get stronger. I mean, right? So look, like this one, like for instance, look, x times x to the what? 3/2. You gotta realize there's a 2 here that you don't see. And then you go, oh, well, this is a 1/1. Oh, no, this is a 2/2 because 2/2 is the same thing as 1. So it's going to be x to the 5/2. And the derivative of that is 5/2 x to the 3/2. And I don't like you writing like that. You should write like 5/2 square root of x to the third. That's the answer. So this is y prime. And then you should be able to answer questions like number 16 and 17. It's a simple test. It's not like the question we did in class. Got it?
Okay.
Wonderful, people. And let's take a quick glimpse of everybody in class, but really fast. So it can't be seen. So that way it doesn't violate the media release form. But I don't have to sign a media release form because who cares about little old me? and